Alright, continuing here on similar figures, page 1.5. We're going to determine if figures are similar, and if they're the same size and shape, it makes it really easy, but sometimes they change size and shapes. So if we use a dilation, right, to change something, right, usually you take the original figure, and as long as the two values of x and y are multiplied by the same, like if x is 3 times the original x and y is 3 times the original y, then it's grown equally, right? It hasn't grown at a skewed rate. So k is going to be the scale factor of both x and y, and the center of dilation is, we could say the origin, but I just wrote it in 0, 0. Alright. Remember, if k is between 0 and 1, it's a fraction that reduces the side. It's a reduction. If k is greater than 1, it's an enlargement. So there's a couple examples down here. Down here, right, if we map RST, this would be RST here, it's a triangle, to XYZ, this would be XYZ here, it's also a triangle. We can see over here that one is bigger than the other one. Alright. Then there might be a scale factor. I mean, what would turn both 0 to 0 and 1 to 3? Well, that would be a k value of 3. What would turn 1? Yeah, 1 times 3 is 3. Negative 1 times 3 is negative 3. Hey, it's working. This time, yeah, it does. So the k value of 3 changes everything in here multiplied by 3 to all these xy values over here. Alright. So we can see the preimage is multiplied by 3 to get the image. So the dilation with a scale factor of 3. Therefore, RST can be mapped onto XYZ by dilation. Alright? That means RST is similar. Let's go down here. Let's do this guy right here. Well, if this is my origin, will this map onto here? Well, if I look at it, and I'm going to zoom in just a little more, this guy is 2, 2. This guy right here is 5, 5, right? This guy up here is 2, 4. This one's 5, 9, alright? This guy right here looks like 6, 4. This guy up here is 12, 9. This guy right here is 6, 2, and 12, 5. Well, you know what I've noticed? Not all these are the same. Like 6 times 2 is 12, but 2 times 5, 2 times 2 is not 5. So there is no k factor, right? So we're going to say not a dilation, not similar, at least for this one. Alright, we're going to keep going to this guy. Let's try this one right here. Alright, so let us look at this next figure. And this one is probably dilated from the origin, so we'll use the origin right here. Alright, so L is 1, 2. Let's go in order. LM is 4, 2. Right? LMN is 4, 6. O is 1, 6. And let's see, I'm just going to write these. So the next one looks like 2, 4. 8, 4. 8, 12. And it's working. I can tell already this is going to be 2, 12. And everything over here is twice the size of everything over here. Alright? So it is. Here's how you would write it. You'd say xy, right, turns into 2x, 2y. They are similar. I'm going to use this symbol so we get used to it. With dilation, scale factor of 2. That cool? Another one right here. Here we go. these guys right here. So what you want to do is you want to make sure that there's some ratio between the sides. And I don't think there is on this one, but let's check it out anyway, right? So if I count here, 1, 2, 3, 4, 5, 6, that's 6. If I count here, 1, 2, 3, 4, 5, 6, that's also 6. So those are exactly the same size, 1 to 1. So in order for these two figures to be similar, the other two sides have to be the same. And this side here is definitely not the same size as this, and nor is this size. Neither one of those match this side right here. So we're going to say not similar. Alright, it's not the same shape and size. There's other ways to figure that out with slope, right? But we're just going to say there's no proportional distance. This is a 1 to 1, and this definitely isn't. Right? So coming over here, this first one right here, let's do the bottom. This has 1, 2, 3, so that's 3, and so is this one up here. So this one over here is 1, 2, 3, 4, 5, 6, that's 6 and 6. Those match up. These are twice, right? If I go here, this is down 1, over 1. So if I did Pythag, the square root of 4 plus the square root of 1 is the square root of 5. Let's check this one out. This is down 1, 2, 3, 4, and over 2. Well, the 4 squared is 16, 2 squared is 4, so this one's going to be the square root of 20. So 3 times 2 is 6, right? And rad 5 times 2, I'm going to say rad 4, this is 2 still, right? 3 times 2 is 6, excuse me, equals rad 20. They do have the same scale factor. So we're going to say similar, and then we will write it. X, Y turns into 2x, 2y, scale factor of 2. So we have two similar figures. I'm going to pause this one. That's 1.5 to 2.5.